Function notation. So here we have y is equal to f of x. This means that y is a function of x here. So here our example, y is equal to 4x plus 1. Or we can say function of x is equal to 4x plus 1. We're meaning the same thing no matter what we're putting here. Y is the dependent variable because it depends on what our x is to get an answer. Our x is the independent variable that we enter in. So our function notation is not limited to x and y. So here we may have a function here, see our cost of quantity is 20 times the quantity minus 5, or depending on what we want to do there. So finding our function values. If function of f of x, is equal to 4x plus 1, we want to find a function of 2 here. So here, function 2 here, so where we have an x, we just substitute a 2 in. 4 multiplied by 2 plus 1 is equal to 8 plus 1 is equal to 9. So here, function of 2, f of 2 is equal to 9. Finding functions values like this allows us to graph our functions in the next section. So here f of x is equal to 3x minus 2. We want to find the following. So for I, f1 here, 3 times 1 minus 2 is 3 minus 2 is equal to 1. For 2, f negative 1, 3 times negative 1 minus 2. This becomes minus 3 minus 2 more is minus 5. And for 3, for 4 is 3 times 4 minus 2. 12 minus 2 is equal to 10. So now we have here our function of q is 200 times q plus 30. So here for I, when our q is equal to 0, 200 multiplied by 0 plus 30 is just equal to 30. For 2, 0.1 here. So 200 multiplied by 0.1 plus 30 becomes 20 plus 30 is equal to 50. And for 3, function of 20 here, 200 multiplied by 20 plus 30. Here is 400, another 0, 4,000 plus 30 is 4030. So now we have a slightly more complicated equation here. Function of x is x plus 12 divided by x. So here, when our x is equal to 2, 2 plus 12 divided by 2, 14 on 2 is equal to 7. So for 2, for 1 is 1 plus 12 divided by 1 is 13 on 1 is equal to 13. For 3, when x is equal to 0, our function of x is 0 here, is 0 plus 12 divided by 0. And 12 divided by 0 is not defined here. So we don't have any result when our x is equal to 0 here. So here we have some typical engineering applications. So here for 1, we want r of 10. And we know, well, here, so it should be 10 squared plus 7 times 10 plus 1. So 100 plus 70 plus 1 is 171. So for 2, we want C 2.5 here. So now we're having our C equation over here, 2.5 squared minus 5 multiplied by 2.5 plus 3. Here becomes 6.25 minus 12.5 plus 3. And together this becomes minus 3.25. So for 3 here, we've got our R equation again, and our q is equal to 0. So r 0, 0 squared plus 7 times 0 is still 0, plus 1 is equal to 1. So for 4, here we've got r of q plus c of q. So here r q plus c of q, we'll put c there. Here is q squared plus 7q plus 1 plus q squared minus 5q plus 3. Q squared plus q squared is 2q squared. 7q minus 5q is plus 2q. 1 plus 3 is 4 here. So for 5, we have r of q minus c of q here. So we have q squared plus 7q plus 1 minus, we'll put it all in brackets to make our negative easier, q squared minus 5q plus 3. So we're having q squared plus 7q plus 1 minus q squared plus 5q minus 3. So q squared minus q squared is nothing. 7q plus 5q is 12q. And plus 1 minus 3 is minus 2 here. And for number 6, here we have RQ is equal to C of Q here. So now we've got our R side is equal to our C side. So Q squared plus 7Q plus 1 is equal to Q squared minus 5Q plus 3. So we move our Q squareds and our Q's over to this side. Q squared plus 7Q minus Q squared plus 5Q, and we move our 1 over to the other side is 3 minus 1. Q squared minus Q squared is nothing. 7 plus 5 is 12Q. Here 3 minus 1 is 2. So Q is equal to 2 on 12 is equal to 1 on 6 here. So our next question is a little bit more complicated, and it's going into our logarithms, which we get to later on. But here we could use a trial and error method, but we're going to go through here. So here we've got our function of x is 3 to the power of x here. And so the way we go through here, we want to find, well, function of x is 243. So we're saying, well, 243 is equal 3 to the power of x, and we want to find x. So we can use log of 243 is equal to x multiplied by log of 3. We rearrange to get x on one side of the equation, divide by log of 3. Log of 243 divided by log of 3 here. X is equal to 5, and if we substitute it in our calculator, if we did 3 to the power of 5, we would get 243 here. So that finds our x here. Is our function of x ever 0? So we're going to go through here. Well, if our function of x was 0, we'd have 0 is equal to 3 to the power of x. So if we think about it, well, 3 to the power of 0 here, that's going to be equal to 1. And we're going to go through, we could go through a few ideas. We're not going to get too far here. So if we do, well, logarithm of 0 is equal to x log 3. X is equal to log 0 log 3 here. And we put this into our calculator, it's not defined. So here, our function of x is never equal to 0. So here we can use our calculator to find different values of our function of x here, and we're using here our exponential function on our calculator. So if you look near the top of the calculator, 2 down from the on button, there's a button here, we'll just put this one here. So on the actual button we have ln, natural logarithm, and above it it has e and a coloured in box there, written in a browny yellowy colour. So that means we're going to use shift here. So to do this one, so f of 0 is going to be e to the power of 0. So we're going to press shift, natural logarithm button here, shift, logarithm, and we're going to press 0 and equals here. So we get that is equal to 1. So for number 2, we're going to do the same thing, but instead of this 0 here, it will be a 2. So here, function of 2 is going to be e power of 2 here, so shift natural logarithm ln here of 2, and we should get 7.4 to 1 decimal place here. For 3, function minus 3 here, e to the power of negative 3 here into our calculator, and we're going to get 0.04978 and so on. But here we're cutting to 1 decimal place. And we have 0 and then 4. It doesn't matter that it's a 9 afterwards. We're just going to round that to 0.0.